Welcome to Brain Vision.
The equivalent resistance of the circuit will be equal to the parallel combination of the bulb and the lower portion of the potentiometer in series with the upper portion of the potentiometer. So plus, because these two are in series, so plus R of, let's call that upper, because this is the resistance of the upper portion of the potentiometer. Now, with the slide at position, let's say X, the resistance of the lower portion is X R V R, and the resistance of the upper portion will be therefore R V A R minus X R var, and this is equal to 1 minus X times R RV. So let's call that RV. Yeah, this will make this will save some time. So now we plug these two, basically the last one over here, and we need to find R parallel. So R parallel, let's call that RP from now onwards. So RP will be, since this is the parallel combination of the bulb and the lower portion of the potentiometer, so we use a reciprocal rule to find the equivalent resistance. So we have 1 over R lower plus 1 over R of bulb, and we take the inverse. And this is equal to, so we plug this value of R lower over here, and we get, after all simplification, we get XRV for R lower times RB over XRB plus RB. So I'm using a RL for lower, RU for upper. Yeah. So now we plug these two in this equation to find the equivalent resistance. So that will be equal to 1 minus X RV for RU plus R parallel or RP, which will be XRV plus times RB over XRV plus RB. And so this is the equivalent resistance of the circuit, and this is the equivalent resistance of the parallel combination of the bulb and the lower portion of the potentiometer, and this is the resistance of the upper portion of the potentiometer. So now we need to know what our current will look like. So now that we have the equivalent resistance, so the current will be current of the loop, let's call that I loop. We can't call this IL because we already have a subscript L for lower. So I loop will be the EMF over the equivalent resistance, and which means that voltage of the bulb will be equal to, so the bulb and the lower portion of the potentiometer must have the same voltage because they are in parallel. So the voltage of the bulb will be, can be written as the current through the loop times the equivalent resistance of this parallel combination. So we write that as IP, RP. And Power of the bulb will therefore be equal to square of the voltage of the bulb over the resistance of the bulb. So now we have all the equations we need. So for part A, consider the case when in which x is equal to 1. So in this case, the full battery potential is across the bulb, and therefore it's obvious that the voltage of the bulb is 120 volt, which means that power of the bulb, which will be given by this equation, this one, the boxed one, so that will be equal to VB square, which is 120 volt, over RB, which is 240 ohms. So solving that, we get the power of the bulb to be 60 watt. Now coming to the second part, we need to consider the case in which X is equal to 0.65, because the resistance is like 65 lower resistance of the lower potentiometer is 65% of RV. So yeah, so now we need to find R parallel. So R parallel will be given by this equation. So we have XRV. So XRV is 150 ohms times RB, which is 240 ohms. Then we have in the denominator these two plus this. And this is basically we are plugging the values in this equation. So this gives 69.33 ohms. Therefore, the equivalent resistance will be, using this equation, will come out to be 1 minus 0.65, which is X, times R variable, which is RV, and that's 150 ohms, plus 69.33 ohms, which is RP, and that we already calculated here, so we don't need to do that all over again. And this will give our equivalent to be 121.83 ohms. So now that we have the equivalent equivalent resistance, so we will go ahead and find the total current flowing through the circuit. So that will be given by the EMF over R equivalent. Now since here X is not 1, therefore we need to do these calculations all over again. However, in the first case, the full battery potential was across the bulb, therefore VB was taken to be equal to the EMF and hence equal to 120 volts. And we need not do these calculations all over again. We did not do these calculations there. So in this part, we don't have x equal to 1, so we need to do all this. So now EMF, that's 120 volt over equivalent resistance, and this gives the current flowing through the loop to be 0.9850 ampere. So now that we have the current, we can find the voltage across the bulb using this equation. So VB will be I of loop times the resistance of the bulb, equivalent resistance of not the bulb, the equivalent resistance of the parallel combination of the bulb and the lower portion of the potentiometer. So that is the one that we calculated here. So we plug that, and this gives the voltage to be 68.29 volt. So now we can find the power of the bulb by taking the square of the bulb voltage and dividing it with the resistance of the bulb. So that gives the power to be 19.43 watt. So that's the power in part B. Now for the last case, oops, our x is equal to 0.35. So we will do the same process that we did in part B all over again. Basically, instead of x equal to 0.65, we will have x equal to 0.35. And we will plug this into all those equations. Oops, all these three, 1, 2, 3, and 4, 5, all these 5 equations. And from that, these are the values that we'll get. So our parallel will be 43.08 ohms. The equivalent resistance of the circuit will be 140.58 ohms. Therefore, now that you have the equivalent resistance, you can find the current flowing through the loop. So that will come out to be 0.8536 ampere. So next step will be voltage across the bulb, that is 36.77 volt. So now you can finally find power of the bulb by taking the square of the voltage and dividing it by the bulb resistance. And this will give the power to be 5.63 watt. So that is the power for the third part.